All right, everybody, this is video 322. We're still working on our second standard, which is to write and interpret absolute value models. So we're going to be working with models, and in this case, our model is going to be a table. So we're going to have tables that are representing absolute value functions. So we're going to go ahead and work with those. So make sure that's on the top of your paper, and when you're ready, go ahead and let's get started. All right, so we're going to be given an XY table, and the first thing we should always check out when we're given an XY table is whether or not we've got a function. And when I examine this table, I go, oh my gosh, my Y's are repeating. But then I relax and I think, it's okay, my Y's can repeat. It's my X's that cannot. So this is looking pretty good. We've got a function. And then I'm going to start examining it to see if it's linear, because I want to know whether or not I'm working with a line or if in fact this does represent something else, maybe an absolute value function. So I start looking for my change in my x's, and I see +1, +1, +1. I keep adding 1. Oh, that's pretty good. Everything is adding 1. And then I go to the y's and I start looking at my change in y's and I go, okay, -1. All right, -1. Wait a minute, now I'm adding 1. So at first I've got this change in y over change in x, and it's -1/1. But then as you continue down here, my change in y over change in x is 1/1. So I seem to have opposite. I have opposite rate of changes for half of my table. And the one that's in the middle here, where it starts to, we see these repeated values start occurring, okay, that's right here at this 0 and 4. So I think, all right, how can I explain this? And so then let's see if we can start forming a pattern. Let's see if something happens here. So I think to myself, all right, I've got this x value, and I'm going to maybe I take the absolute value of it, and then I get 7. And let's see what happens. Now I have the absolute value of something, and I get 6. So that's I'm taking these x values and I'm trying to get a y value. Remember, those are my input, and I have this output. Okay, so my input values, they make up the domain. The input values make up the domain, and my output values make up my range. So I'm just trying to work with that. And then I say, all right, -1 when I take the absolute value, somehow maybe I get a 5. And then I have this 0, and I get a 4. Well, that seems easy. All I have to do is add 4 to that one. Huh. I wonder if it works on the rest of these. If I take the absolute value of -1 and I add 4, I get 5. If I take the absolute value of -2 and I add 4, I get 6. And it also works on this one. So that was halfway through the table. Let's see if it works for the last 3. If you take the absolute value of 1 plus 4, I get 5. The absolute value of 2 plus 4, I get 6. And the absolute value of 3 plus 4, and I get 7. So in fact, if I take the absolute value of the x and I add 4, I get the y value. And I have written a model for this table. This could also be written as the absolute value of f of x equals, f of x equals the absolute value of x plus 4. So both of these are acceptable models to represent this table. Let's go take a look at another one. All right, let's check out to see that we've got a function, and I see no repeated x values. Y's seem to be repeating, and they kind of repeat in that similar ways. That I've got these pairs that are matched up, and well, I wonder if I had a -9, maybe I would get a 14. I don't know. So let's check out my change in x. So it seems that my change in x over here is +3, +3, +3. That seems to be consistent. How about my change in y? -4, -4, +4, +4, +4. Oh, well, -4 would give me that one. All right, let's see. And it would also work over here. So my change in y over my change in x is -4/3. But down here, my change in y over my change in x is +4/3. So once again, I have opposite rate of change. So let's take a look at a pattern. Wonder if I take the absolute value of that x again, just kind of like the last one, and somehow I get 14. And if I take the absolute value of the next x, somehow I get 10. Now, this is 9. 9 plus 4 equals 14. That's not going to work. And the absolute value here is absolute value of 6 plus, well, that'd be 5 to get me 10. And the absolute value of negative 3 to get a positive 6, well, that'd be like adding 3. So it doesn't seem as though if I add 4, if I add 5, that's not really the same pattern. So that's not going to work. I'm going to actually erase that. But what I didn't take into consideration is that my rate of change is not 1. My rate of change is a negative 4/3 or a positive 4/3. So I wonder if that has anything to do with it. So if I slap a 4/3 on the front of this, how about 4/3 times the absolute value of negative 9? Does that equal 14? Well, if you go ahead and then I take, well, let's try it again. Absolute value, let's just try, because I think we need a pattern before we just make any conclusions. So now, if you multiply 9 times 4/3, because it's the absolute value of negative 9. So 9 times 4/3 is 12. 12 to 14, that means I would have to add 2. Let's check it for the next one. 4/3 times negative 6 is 8. 8 plus 2 equals 10. See if it continues to work. 4/3 times the absolute value of negative 3. The absolute value, that's a 4. 4 plus 2 equals 6. So all of these would work if I put a 4/3 in front of them. Now you might be thinking, why didn't you put a negative 4/3? Because on those values there was a rate of change of negative 4/3. But I know that if I multiply a negative on the outside of my absolute value, that I would end up with a negative 14. And I don't want negative 14. I wanted a positive 14. So I'm going to keep this rate of change in front, kind of like my slope, as a positive value. Let's double check to make sure it works on the rest. 4/3 times the absolute value of 0 plus 2 equals 2. 4/3 times the absolute value of 3 plus 2, that's a 4 plus 2, that equals 6. So now we got all of these so far. And then I've got the last 2, 4/3 times the absolute value of 6 plus 2, this is 8 plus 2, that equals 10. And lastly, 4/3 times the absolute value of 9 plus 2 equals 14. So in fact, it does work. So here we have 4/3 times the absolute value of x plus 2 equals y. And this is the model of this graph. You may also write that with f of x. We got one more. Let's check out to see that this is a function. None of my x's are repeating. So the next thing we look at is whether or not this is linear or if it might be something else like absolute value. So I start by checking the change in x's. And my change of x's here are plus 2, plus 2, plus 2, plus 2, plus 2. I'm counting by 2's. Over here, ooh, I seem to be going up by 2 and then up by 2, and then now I'm going down by 2 and down by 2. So those are my change in y. My change in y over my change in x on the first few are 2 over 2, or 1. And then as I get down here, I have the change in y over the change in x as negative 2 over positive 2, or negative 1. So once again, I have an opposite rate of change. That's modeled in my table. Now I'm going to have to try to interpret this, and we're going to form a pattern once again. What I learned from the last one is that I needed my rate of change to sort of be my coefficient, the number on the outside of the absolute value. In the very first example, that number was 1, so we didn't even bother writing it. In the second example, the number out front was 4/3 because we had this rate of change that was not 1. In this case, we have a rate of change that seems to be a 1 or a negative 1, and we're going to have to work with that. So let's just take a look here and see what we get. If I take the absolute value of negative 4, how do I get a negative 8? And if I take the absolute value of negative 2, how do I get a negative 6? If I take the absolute value of 0, how do I get a negative 4? Well, that's really interesting. What are we going to do? So this is really, really interesting here because I have a negative outcome at the end. So how am I going to show that? And I think, well, if I have the absolute value of negative 4, which is positive 4, but I have to get to negative 8, then I would have to subtract 12. Remember, this is positive 4 minus 12 would be negative 8. Let's see if that works on the next one. What if I have the absolute value of negative 2? That's positive 2. How do I get to 6 from positive 2? I'd have to subtract 8. All right, well, I need to be consistent with this number right here. And I don't seem to have a consistency, because here I would want to subtract 4. Well, let's try the next one. The absolute value of positive 2. Well, if I subtract 4, do I get negative 6? Nope, I get negative 2. So this one doesn't work. And then these don't have the same consistency. So here what we see is that if I started with a positive rate of change and then I have a negative rate of change, that I might have to change something up. I might have to make an alteration. And in fact, what we're going to do is we're going to take the opposite of the absolute value, and then let's see what happens. Because it's the opposite direction. Before we were subtracting and then we were adding, and that's not the case in this one. So let's see if I do this. And then I subtract 4. Do I get negative 8? Ooh, it works. Negative 2 minus 4, that equals negative 6. Negative absolute value of 0 minus 4. Well, of course that one works. Let's see if it works on the next one. Negative absolute value of positive 2 minus 4. That equals negative 6 again. We got 2 more to check. Negative absolute value of positive 4 minus 4 equals negative 8. Negative absolute value of 6 minus 4 also equals negative 10. So in this case, we had to, because it was happening in the reverse direction, we have to put an opposite sign on the outside of our absolute value. Then we can subtract 4 and we get y. So this is an example of an opposite absolute value. That negative out front makes it the opposite. Again, this can also be written as f of x equals the opposite of the absolute value of x minus 4, if you wanted to write it in function notation. Both are acceptable. All right, there's going to be 2 questions on an entrance slip, so why don't you go ahead and give those a try, and we'll talk about the rest of this in class together. Great job.